In the last lesson, we learned what electricity really is. Positive electrical charges flowing through a circuit or wire to negative electrical charges, also called ground. In a perfect world, it is really as simple as that. However, our world is far from perfect, so there's more. In the world of electronics, there are two types of materials that connect a circuit together: insulators and conductors. A conductor, like copper or aluminum, can easily connect an electrical circuit together, and it will operate as we expect. An insulator does the exact opposite and allows virtually zero electrical current to flow through it. Let's perform an experiment to see the difference between a conductor and an insulator. For this experiment, we will use a digital multimeter. Switch it to the continuity setting indicated by this wave-like symbol. If we touch the red and black probes together, you can hear a short beep. This beep indicates that electricity can easily flow out of the red probe and into the black one. This digital multimeter function is known as continuity testing. Here, I have some random items from around the house. Let's use the continuity tester on the digital multimeter to see which items allow electricity to flow through them and which items do not. Polyester does not. Glass does not. Wood does not. Rubber does not. Steel does. Plastic does not. Aluminum does. Aluminum foil does. Silver does. Copper does too. As you probably noticed, most metals will allow electricity to flow, while most non-metallic objects do not. So why is this? Let's get it explained. As you saw, conductors and insulators can be found all around us, and what you just witnessed was the basic idea of electrical resistance. Resistance is an element in an electrical circuit that acts like a funnel for the electrical charges or current flowing through it. This means that the larger the electrical resistance in a circuit, the smaller the amount of electrical current that can flow through the circuit. The non-metallic objects from the previous experiment acted like a resistor with a large electrical resistance. In fact, it was so large that the multimeter didn't beep, telling us the material is an insulator. The aluminum foil, on the other hand, had a close to zero electrical resistance because it is a great conductor, and the continuity tester beeped right away. In electronics, electrical resistance has been harnessed into a component called the resistor. Resistors come in a variety of shapes and sizes, and each resistor will have some markings to represent how much electrical resistance it can provide. These resistors are called through-hole resistors, and they have 4 or 5 colors that represent their electrical resistance value. These much smaller resistors are called surface mount resistors. The 3 or 4 numbers written on top of them represent the electrical resistance of that specific resistor. Let's perform another quick experiment. You will need a breadboard, a 9-volt battery, a 9-volt battery connector, a red LED, and some random resistors from the parts kit. First, connect the 9-volt connector to the battery and connect the red and black wires to the power bus on your breadboard and the ground bus on your breadboard. Then, put your LED into the breadboard with the shorter wire connecting to the negative or ground and the longer wire going into any of the generic breadboard holes. Now, one at a time, connect each of the resistors that you have from the LED to the power bus of the breadboard or the plus side, as I am doing. After putting in a few resistors, you will begin to notice that some resistors make the LED brighter and other resistors don't even allow the LED to turn on, even though it's connected to power. So now we have to ask ourselves, what is actually happening here, and how do I know which resistor is what electrical resistance? To start, electrical resistance is measured in ohms, the capital Greek letter omega. For example, 1000 ohms or a 1 kilo ohm resistor is a common value used in electronics. The relationship between electrical voltage, current, and resistance is called Ohm's law. Ohm's law states that the voltage between 2 points is always equal to the product of the current in amperes and the resistance. A simple example looks at our previous experiment. We used a 9-volt battery and I had a 100 ohm resistor. Plugging these two values in, we can solve for the current, 0.09 amp or 90 milliamp. Notice that if the resistance becomes larger, say 10,000 ohm, the current would only be 0.9 milliamp, which is much smaller and part of the reason why the LED slowly became dimmer with certain higher value resistors. Let that sink in for a while and let's move on to identifying resistors. If we take a look at through-hole resistors, we can see there are 4 colors. These colors represent numbers. On the left side of the screen you can see which color goes with which number. To calculate the value of this resistor, match the colors to the numbers. And then the first 2 numbers are multiplied by 10 to the exponent of the third number. For example here, 47 times 10 to the 2, or 4700 ohm, or 4.7 kilo ohm. And then the fourth color represents the tolerance. Here it is plus or minus 5%. Which means the actual electrical resistance value can vary for this resistor by 10%. This tiny component is called a surface mount resistor because it attaches to the surface of the electronic circuit board. We see there are only 4 numbers on the top. Again, the first 3 numbers are called the significant figures, and the last number is used as an exponent in 10 to the x power. And so the value of this resistor is 464 times 10 to the 1, or 4.64 kilo ohm. The theoretical symbol for a resistor looks like this lightning bolt. And in schematics, you will always want to give the symbol a name like R1 and a value like 4.7 kilo ohm. Let's put this new knowledge to use by drawing out a circuit schematic and then actually building it. First, we draw the symbol for a battery, which looks like this. Then, we connect the positive side of the battery to the resistor. An LED connects to the resistor, and its symbol looks like this. Finally, the LED connects to the negative side of the battery. Make sure to give all of your parts a name and a value as I have. With our schematic drawn up, we can now build the circuit. We'll need all the components to build it: a 9-volt battery, a 9-volt battery connector, a breadboard, a 470 ohm resistor, that's the colors yellow, violet, brown, and gold, and a red LED. Now, just as we did in the previous experiment, connect your 9-volt battery to the breadboard using the 9-volt battery connector. Next, connect the 470 ohm resistor from the red power bus to any generic spot on the breadboard. Finally, connect the LED to the circuit by putting the shorter pin of the LED into the negative side or ground on the breadboard, and then connect the longer pin of the LED to anywhere in the same row as the resistor. Ta-da! The LED turns on, and our circuit is complete. Resistors and electrical resistance are a core property of all electronics. If you take a look inside any of your electronics, like this computer card, you will see tiny resistors all across the board. Again, these are called surface mount resistors, and each resistor has a specific task and resistance value in ohms that allows the board to operate. Let's take another quick look at some resistors before we finish. Here we have a cheap remote-controlled car. When we look at the electronics inside the car, we see again that resistors are all over the place, and that they're even labeled R1, R2, and etc.
All parts in this online course were provided by the Gadgetory. Visit them at gadgetory.com/PyroEDU.
Thank you for watching an Intro to Modern Electronics, the resistor. If you're ready for more, please continue on to learn about the capacitor. Or you can go back and study electricity.